Comes on everyone. Let's start off with this. Find the height of the building. Hmm. Right there, yeah. Right behind. So how do we do this then? So initially the speed is 20. Let the speed when it lands is v. We know u cos 30 is equal to v cos 60. Kinematics, the horizontal velocity is constant. So indirectly, that would be u cos 60 is equal to v cos 30. So this is 20 by root 3. That is your v. Then conservation of energy, half m20 square is equal to mgh half m20 by root 3 whole square. There. Kinematics and conservation of energy. 40 by 3 meters. Easy? This is how the questions will be. They'll be easy. They'll be not too out of the world or something. But you need to know what you're doing. You have to think a bit. Let's get these things. A particle is projected with speed u at an angle theta with the incline. It hits the incline perpendicular to the surface. Find the relation between theta and alpha. Second question. The particle is thrown from down with speed u. The particle is thrown with speed u from the top. In both the cases, the maximum range is R1 and R2. If R2 by R1 is 3, find alpha. In case you forgot, these are the formulas for maximum range on an incline. You need to remember those results. Exam, you won't have time to derive. How do we do incline problems? We resolve the acceleration along the incline perpendicular to incline. Remember, you treat that as x and y axis. Right, Vihan. So how we do? We resolve this acceleration. So we treat this as x-axis. This is your y-axis. This will be g sine alpha. That's your ax, and this will be g cos alpha. Similarly, velocity can be also resolved into u cos theta and u sine theta. What is time of flight? Time of flight depends only on the vertical, which is 2u, 2 vertical by a vertical. Here u vertical is u sine theta, and vertical direction, that is y direction, is g cos alpha. You want to find range? I didn't ask you that, but if I wanted range, then I'll use Sx is equal to ux into time of flight minus half g sine alpha t square. This would be the range on an incline. He was saying it will hit perpendicularly. So if you're hitting here perpendicularly, that means you have Vy here, but Vx is 0. So Vx is equal to Ux plus Axt. So if you're hitting the surface perpendicular to the incline, there is no horizontal component. Ux is u cos theta. Ax will be g sine alpha time of flight. It will be u cos theta, g sine alpha, and time of flight is 2u sine theta by g cos alpha. So we get tan theta, tan alpha is equal to half. As long as you satisfy this condition, it will always hit the incline perpendicularly. Clear with this. If they ask you for range, this is the formula for range on an incline. All got this? In case you forgot, should definitely go check it out. Incline problems are important. What about this thing, the maximum range? There, look at the formula here. If you're throwing from down, the maximum range is u square by g 1 plus sine alpha, and theta must be pi by 4 minus alpha by 2. If you're throwing from top, it is u square by g by 1 minus sine alpha. It is given in the equation r2 by r1, which is u square by g 1 minus sine alpha by u square by g 1 plus sine alpha is 3 is to 1. The 1 plus sine alpha by 1 minus sine alpha is 3 is to 1. Solve this, you'll end up with alpha is equal to 30 degrees. Clear with this thing. This question is actually tough. But if you know the result, it becomes easy. If you don't know the result, then it is a lot of work. Everyone knows the formula for the maximum range on a horizontal thing, but this is a different thing though. Clear with this. So remember that in case you forgot. What about these two? The particle is thrown with u and theta, it goes and hits a wall at 2r by 3 and lands on the ground. E is the quotient of restitution. Find x. Second case, two parallel walls, distance between them is 3r by 13, E is equal to 1 on both the sides. You project it with u and theta. Find the point where it lands. So this will bounce, 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 and land somewhere on the ground. I can add one more question. This we did in the class notes also, in collisions. This is E, this is E. Ball is projected with u and theta. It goes there and collides at h max. Then it comes and lands on the ground. And then again it bounces and goes back to the point of projection. Find E. Let's get them all. Let's get the first two. First two are actually easy. Second one still requires little work. R is the range. So you're hitting at 2r by 3 in the first case. So you're not hitting at h max. I would do the first one. See. So think of like this. If there was no wall, what would have happened? You would have just gone straight and you would have landed at r by 3. So at this point, your velocity would have been how much? U cos theta. If you're hitting a wall with speed u, then you'll bounce back with the speed of eu. So this speed would have been eu cos theta. Now think about this. So you have two particles, both are thrown from the same height, right? So the range will be, when you throw from a building, the range will be ux into time of flight, which is ux into root over 2h by g, proportional to ux. So both are same height. That means it only depends on the horizontal velocity. So for speed u cos theta, if you travel r by 3, then for speed eu cos theta, you will travel e times r by 3. Is that making sense? If e is equal to 1, you would have bounced back r by 3 just like a mirror image. Isn't it? Only the horizontal component changes, isn't it? The vertical component is unaffected. I know I can't use this formula because there is no horizontal velocity, but फिर भी, this guy will be whatever is this ui. This ui also will be same. So time of flight will be same, isn't it? Since ui is same, they'll have same time of flight. So range depends on the horizontal velocity. Is that clear, everyone? What about the next one? Similar story there. Suppose if there were no walls, you would have completed a full thing. Now think of this. Every time you hit a wall, you're simply, instead of going front, you're coming back. E is equal to 1. So you cut this entire parabola into pieces. How many pieces? 3r by 13, 3r by 13, 3r by 13, 3r by 13. The total it has to be r. And the last piece will be r by 13. So let's name the point here. So let's call this thing 1. So let's call this point 1, 2, 3, 4, 5, and 6. So 2 will be on the right wall, right? And so you're just, flipping right and left. So this is the right wall. Then you hit the left wall, point 3. Then you hit the right wall again at point 4. Then you hit the left wall again. So you actually come something like this. And then you fall on the ground. This will be 5 and this will be 6. Are you clear what I'm doing? I just took that parabola and I folded it every 3r by 13. I kept on folding the parabola between the walls. So where will it land? It landed in distance of r by 13 from the left wall. Make sense? I hope that idea was clear. Because see now, E is equal to 1, that means horizontal velocity won't change. So whatever is supposed to happen on the right hand side, the same thing will happen on the left hand side, like a mirror image. The walls will never change the vertical velocity. So if they ask you find the H max, H max will be same. So in this case, H max will be u square sine square theta by 2g. If you ignore the time of collision, time of flight also will be same. Since during collision with the walls, the vertical component is unaffected, time of flight and H max will not change. Clear with this? What about this guy? Hits the wall, falls on the ground, and bounces back. Find D. It is hitting the wall at H max, huh? So that means this guy is R by 2. Try, I'll give you 2 minutes. How do we do this? So when you hit the H max, speed is u cos theta. You will bounce back with EU cos theta. That means you will go and land at a distance of E times R by 2. Now, when you go and hit the ground, your vertical component will be U sine theta. The horizontal component has become EU cos theta. And you're hitting here and you're bouncing off. So again, now when you hit the floor, only the vertical component will change. That will become EU sine theta. And the horizontal component is EU cos theta. So now you got a ball which is going with EU sine theta and horizontally with EU cos theta. This is going and landing on the ground. So time of flight will be 2 times EU sine theta by g. Range will be EU cos theta to EU sine theta by g. This will be E square R. That means after hitting the ground here, this will land here. This distance will be E square R. But we know this total distance is R by 2. So E square R plus ER by 2 is equal to R by 2. 2E square plus E minus 1 is equal to 0. E is equal to half. Clear with this? So when you hit the wall, horizontal component change. Basically, velocity will become E times only along the normal. So when you hit the wall, horizontal component changes. When you hit the floor, vertical will change. But understand, when you hit the floor, what horizontal already changed. So after hitting the floor, it feels both the components become E times. So the range becomes E square R. Clear with this? Collisions and kinematics. So questions will be of this sort you're getting, and no one is just going to ask you pure kinematics. Mains may फिर भी 1 or 2 questions they will be direct, right? But that way, let's get these two. We have a river which is going with you, and we have a man who can swim with speed v. This guy is swimming in a square. So when you look from outside, he's actually swimming in a square. He's not trying to swim in a square. He's swimming in a square. He's going from A to B when the river is flowing this way. Just to give an idea, do you think he's swimming straight? If he swims straight, he can't go in a square. He must be swimming at an angle. The net force must be pushing in the vertical direction. Find the time taken for one revolution. Second thing, the man is walking on an incline with speed u. Rain is falling with 10 root 3 at 30 degrees. Find the speed of the man if he thinks the rain is falling vertically. The 29A literally covers the 3 models of the river boat. Right, Johan. That's what I'm saying. It takes a minute. If you actually went through the nodes, you will know the results. And it will take less than a minute to solve that thing. The problem is you will try to solve now. You will lose time and you're gone. Standard questions, you don't have time to solve in the exam. You do that, you can't score 180 plus. You're aiming for 180 plus, 200 plus. You should know certain things. You should see and be able to tell the answer. Because your plan is to cross 200. Physics and chem will push your score to maybe 160, 170, 150, 160 stuff. Without max, you're not going to push more than 200 plus. Unless physics and chem you put 200s. What are the results? Forgot. See. When you're going straight, in case you forgot, I'll just show you the results. That would be faster. The exact same question. Question 70. But anyway, let me show you the results. First case, if you go with the river, speed is v plus u. Go opposite to the river, speed is v minus u. Case 2, minimum distance. When you're going opposite to the river, opposite point, you're swimming at a v at an angle theta. Sine theta will be u by v, and the time taken is this dy root over v square minus u square, because you're swimming with the speed of v cos theta, right? So in our square ka problem, when this guy is going straight, the time taken will be L by root over v square minus u square for AB. For BC, it is L by v plus u. This is L by root over v square minus u square. L by v minus u. That's the time taken for each section. This is for DA. That's it. Add up, you'll get the answer there. What about this thing? Whenever man is walking like this, you resolve the velocities into components. U cos 37, U sin 37. These umbrella problems are the easiest ones, right? You just need to resolve the velocity into components. This will be 10 root 3 cos 30, 10 root 3 and sin 30. And always stop the man. If you stop the man will think, okay, I came to rest. And he will start thinking the rain, this is 10 root 3 cos 30. The horizontal will be u cos 30. When you stop them and what you do, you take these velocities and add them in the reverse direction. Ten root 3 sine 30 and u sine 30. Since he thinks rain is falling vertically, horizontal component should cancel. U cos 30 will be 37. 10 root 3 cos 30. Solve this, you'll get the answer. So yeah, Rain Man, there is nothing much. Always stop the man, take the relative velocity and see what he's asking. I hope you remember these problems. Four particles on a square, they're chasing each other. Find the time when they meet and distance traveled. So we have done this extensively, you have some pretty good advanced problems. Find the angle rotated by the particle as function of time t. We did that in circular motion. Find the time when they meet. And if you take the center as O, find angle rotated by OA vector in time t. In case you forgot this, you will not find in kinematics, you'll find this in circular motion. There. So I did for a triangle though. So three particles are going around, round, round. So these are the velocities, and then you have to integrate and you'll get something of this sort. It's based on rotation there. Anyways, give it a try and I'll show you. Yeah. Get these two. The time was the easiest one. That you should know how to do. Right, Niharika. Very hard. Get the second part also. Try the first one. I'll give you 2 minutes for the first one. It's a worthy one. Circular motion and kinematics, and that would be a pretty good advanced question though. If I just ask you for the time or the distance travel, that's still easy one. That's a mains question. Now again, when I say mains question, understand you'll be writing two mains, two bits, CET, UG exam. That's almost 7 exams. Somewhere it will pop up. Let's see. These kind of questions, right? Now, when you have the four particles, understand something here. The particles are coming towards each other. This is going with u. If you resolve the velocities, this is 45. In case of a triangle, it will be 30. So you have u cos 45 and this will be u sine 45. Similarly, if you resolve for everyone, you will be u cos 45 and u sine 45. U cos 45, u sine 45. U cos 45, u sine 40. You can clearly see something here. The u cos 45s are responsible for shrinking the square, and u sine 45s are responsible for rotating the square. So after some time, the square will become smaller and will also rotate. Even then, if you try to resolve the components, now the angle toward the center will be always 45 only. You're still going with u cos 45 toward the center, and your u sine 45 are still making you rotate. Clear with this? So that is a main theme in this kind of questions. One component is making you go in a circle, one component is bringing you closer and closer. So the triangle is shrinking, 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 and eventually becomes, if you actually try to look at the path of A, it looks something of this sort. It's a spiral. This is how the path would look. Right? So you want to find the time, it's straightforward. So time will be distance from A to O and velocity along A to O. It's like displacement by velocity in that direction. So A to O will be half of the diagonal L by root 2, and this guy will be V cos 45. That will cancel L by V. Straightforward, done. Got it? It's a hexagon, you can do the same thing. You can do for any symmetrical shape though. You want distance. Distance is speed into time, which is U into T. That will be VL by VV. So that spiral ka length is actually L. But you want to find the angle rotated. Now it requires little work so that OA final. So OA at time T, the distance will keep changing. This will be L by root 2 minus U cos 45 minus U by root 2 time T. So, and omega will be V tangential, which is U sine 45 by OA. So your omega is changing with time. So that will be 1 by root 2. That will cancel L minus ut. This is your omega, and this is d theta by dt. Integrate this. You end up with theta is equal to minus ln L minus ut. So that would be L by L minus ut. Something like this you will get. You can integrate this and you can get theta from there. So minus 1 by u will go off, ln L minus ut, put 0 to t. So when you put 0, you'll get an L, and when you put t, you'll get L minus ut minus A. That's your angle divided as function of time t for t less than L by v though. Because after L by v, they're going to meet, the formula won't be valid anymore. Is that clear, everyone? And there's one more important thing, an advanced thing here. If they ask you find the acceleration of this particle, this we will do it again in advanced revision. But I'm just giving the formula. The formula is v into omega. Speed of the particle into omega is the acceleration. So we will talk about that later on. For now, it's not that important. Because here, if you see, the particle speed is never changing. So there's no tangential acceleration. So it's the r is changing. So there's a radial acceleration, d square r dt square and all that stuff. We'll see later on. What about the second one? The wind is blowing northeast, vehicle moves east. There is a flag on top of the vehicle. Find the direction of in which direction is the flag points. These are another important questions, flag questions. So if you see in relative motion, right, the important variety was this. Minimum distance between the particles, the condition for collision, rainman, riverboat. Riverboat, remember, there's one more condition. If the speed of the man is less than the river, then what is the minimum drift? Case 4 था वो check कर लेना. Answer is the same thing. Sin theta will be v by u. Case 1, when he crosses the opposite point, sin theta will be u by v. Right? And then we have these flag problems, and then you have particles chasing each other, the cat, dog, and all that stuff. So, but cat dog, I don't think they'll ask. So this will be the mostly a mains level thing. They'll stick to this only. So this will be all those stuff. What is the answer for this guy? You can think about this. If you're sitting on a vehicle, right, and the vehicle is going forward, which way will the flag point? Backward. If you're standing on the ground and if you lift your flag and the wind is blowing, which way will the flag point? In the direction of the wind. So flags will always point in the direction of the wind and opposite to the direction of the vehicle ka motion. And if both are moving, then you take the resultant of these two. Wind is blowing northeast, so flag also will point northeast. Remember, this is my north, east, west, and south. Vehicle is moving east, so the flag will point west. This is due to vehicle. This is due to, and that's it. And then take the resultant of these two. You can clearly see the horizontal components cancel. This will be the vertical component. So north. Easy equations. They do ask such kind of stuff. People see the flag and all and they get scared. That is because you have not seen such kind of a model. And that is the whole point of this session. It is to get you exposed to as many different as models as possible. When you go to the exam, if you see something like this, you should not hesitate. You should know what to do and you will just finish it off in a minute. Clear this. There, this is for the three particles, if you remember. 2 blocks. Find the acceleration center of mass. I hope you guys remember the formula for Atwood emission. 2m1 m2 g by m1 plus m2. Acceleration is m2 minus m1 g by m2 plus m1. So you have 2 blocks, m and 2m, released from rest. Find the acceleration center of mass. Acceleration of blocks is too easy. So very much. Easy one. This guy will go with acceleration g by 3. This will go with acceleration g by 3. Be careful. This is minus j cap, that is plus j cap. Acceleration center was m1 a1 plus m2 a2 plus by m1 plus m2. You will get minus g by 9 j cap. If you forgot the sign, you will get g by 3. So just be careful with that. It's an easy one. Let's get these two. 4 questions. Find the acceleration of all of them. This is the main question. That is just a starter to make you feel good. Let's get this. You can handle these 4. I think NLM ka all these pulley problems and string problems you can handle. Get them all. I'll give you 5 minutes. In case you forgot, what are the steps? How do you solve NLM problems? Interesting. Where did we write that? Here. This is finding tension in the string. Anyway, let me tell you that. Step 1, choose a system, draw the FBD. Step 2, define accelerations, SN accelerations for the bodies and find the relation between them using constraints. Step 3, apply F is equal to MA in horizontal and vertical direction. Step 3, solve. That's it. Draw the FBD. Assign accelerations. Right? Don't assume they will always have same acceleration. They might be different. In this, if you ask me, C and D are good. E is also good. If I put friction, that becomes more deadly, but okay. Should I show you one? See the this one. Step one, draw the FBD. Tension. This guy will be 2 times tension because there are 2 strings. This is mg, this is mg. Next step, S and accelerations. Let's say if this guy is going up with A, right? This guy will go with A by 2. I hope you can see and tell. You don't know how to do that? Let this go with A2, let this go with A2, A1. String constants. How to do the string constants? Tension into acceleration. T1 A1 plus T2 A2 plus T3 A3 must be 0. That will be tension. A1, this will be 2 times tension minus A2 is equal to 0. So we get A1 is equal to 2A2. This is the relation between string constants. Forgot, go and check the notes. So that means if you take this guy as A, this guy must be 2A. You can clearly see there are 2 strings there. Every time it moves, the other block goes to double the acceleration. Write the equations. T minus mg is equal to m into 2. This will be a pretty good mains question. They can ask you such kind of things. Not too tough, but people who just mug up the formulas and go like, this thing m2 minus m1, or people who don't know the string constant, they'll goof up and come. This will be mg minus 2t is equal to m into a. You're done. Take this t, dump it here. This will be mg minus 2, that will be mg plus 2ma is equal to ma, that would be minus mg, a is equal to minus g by 5. There, I thought it will go down, but it is actually going up. The sign will take care of it even if you have wrong acceleration direction. So this guy is going up and the other one is coming down. Easy? That's it. This is what you do. Get the rest. Idea is the same. D is a little deadly if you try to do it normal way. There's the thing I taught you for that also. Pulley equivalent. E, capital M and small m. Don't take same as for E. This guy, masses are different, capital M and small m. Try. Give them a try. I'll just get some water and come. Let's see the next one. Same story. This would be tension T. This would be T. This would be 2T. This would be 4T. If I assume this is A1, this is A2, this is mg, this is small mg. 70 into minus A1. So total tension on the block into the acceleration, up is positive, down is negative. This will give you the constant equation. 7A1 is equal to A2. And if you write the equations, mg minus 70 is equal to m into A1. T minus small mg is equal to m into A2. There are three equations, three unknowns. You can solve, you'll get the answer. Now this thing, the pulley equivalent. In the Atwood machine, if you have block M1 and if you have block M2, if you remember, this was tension T, this was T, and this was 2T. The tension was 2m1 m2 by m1 plus m2g. That means if you ask the ceiling boss who is hanging there, the ceiling does not care whether you keep a block there or a pulley there, the tension must be same. So this m equivalent is nothing but m equivalent into g is 2t. You end up with m equivalent is equal to 4m1 m2 by m1 plus m2. And the best thing about this formula, this works even if the ceiling is accelerating. You can prove that, but that's your result. So whenever you see an Atwood machine, a pulley with two blocks, be careful. You suppose if I have a pulley here, if you have something like, you cannot use it for this. There has to be two blocks. Now coming back to our problem. This was 3m. This was m. This was 2m. So you can replace this whole thing with an m equivalent, which is 4 into m into 2m by 3m, which is 8m by 3. Now it becomes a regular Atwood machine. This is 3m, 8m by 3. So this is tension. This is tension. I can find the tension here. I can actually get the acceleration of 3m directly, which will be 3m minus 8m by 3 by 3m plus 8m by 3g. But if they ask you for the acceleration of m or 2m, then there's a little more work involved. This will be 2 into 3m, 8m by 3 plus 3m plus 8m by 3 into g. This is the tension. Now go back to the previous shape, the normal one. So indirectly, what did you find was this tension. You found this tension. So this tension will be T by 2, this tension will be T by 2. There, now you know the tensions. Let this be A2 and let this be A1. So T by 2 minus mg is ma1. Take T by 2 ka value and substitute here. T by 2 minus 2mg is equal to 2ma2. That's how you get A1 and A2. Clear with that. If they ask you find acceleration of 3m, question gets over here only. But if they go more deep and ask you find acceleration of that m block, then you have to find the tension. Then go back to the original shape and then finish it off. All clear with this? Getting it? This is pretty nice. Matlab, you can use this even if someone had given you block, 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 and a block. 4 blocks, and ask you acceleration of each block. It works. And if you remember in the class notes, we have done block, 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 infinite pulleys. That was some pretty nice question. You should check it out. But again, I don't think they'll touch that. What about the E1? If you see, B and C are kind of similar, but D and E will be again a different variety though. In the class, two things should happen. Either you should get overwhelmed, oh, what is this? What is this? What is this? That's a good thing. So after the class, you can sit and learn, okay, this is all the things you forgot. Or what I'm saying, you're getting the answers. So either way, it's a good thing. So don't get scared like, oh, I'm not getting all these things. Think of this way. Good thing, that you at least came to know that you're not getting all these things. You have time. You just need to learn, and you'll be fine. विहान देखो आंसर में when you have strings and blocks you can never get an answer greater than g इतना याद रखो a block cannot go faster than g when strings are involved ठीक है just keep that in mind. It's okay if you get a wrong answer you shouldn't have made it as a blunder how to do this thing near and abhi 5 आएगा डिनोमिनेटर में चलो चलो everyone focus like I said you're sitting and studying with me don't chill out there is one idiot who is chatting in the chat box and not even doing it privately. The problem is not that you're doing some nonsense. You guys are so dumb that you're getting caught also. Tomorrow when you join in a corporate, I don't know how you will guys survive, or when you start your own company, I don't know what will happen. Let's see. Nere Vehan, that is wrong. Look at this. This is a good one. This section, right, literally contains all those stuff. So here there are few things you need to take care. The regular string constant won't work because it's touching each other. This is M. The first common thing, most people go for the FBD. Let's see whether you got the free body diagram right. Remember, in a free body diagram, the pulley is part of the system. The pulley is fixed to the wedge. So you have to include the wedge also, the pulley also in the free body diagram, meaning you have to include the tensions also. Most people forget that part. They don't include the tensions in the string which are connecting that. And remember, strings always pull. So that T will be there. This normal reaction, your own weight mg, and this is n ground. Perfect. And for the small block, we have tension, normal reaction, and small mg. There, these are all the forces. If you have friction, that becomes more complex. Next thing, acceleration. If this thing goes forward with A, because both are touching, this also should go with A. And also, every time it goes forward by A, can you see this thing here? This part of the string and this part of the string, two strings get loose. That means this thing will travel two-way down. That's your constraint there. Every time the big block moves by distance A, the small block will travel downward by 2A. Are you clear with this? And then you're done. Once you got these two, you're done. In NLM, that is the thing. If you can draw your FBD and constraints, question is over. So horizontally, it will be T minus N is equal to capital MA. This guy will be mg minus T is equal to M into 2A. Horizontal direction N is equal to MA. Substitute, substitute. This will be mg minus 2MA minus MA is equal to MA. Something I missed, I guess. There is one more tension here, I forgot. There is a one string also attached here. So this guy will be 2t minus n. So this will be 2 times. So A will be 2mg by m plus 5 small m. That's your acceleration. Clear with this? See where it went wrong. Did you forget the FBD? Did you mess up the constraint? Every time the big block moves by A, the small block will travel down by 2A. Clear? And there is one more type of question. Okay, there are 6 blocks. Find tension in this string. All surfaces are smooth. There's M1, M2, M3, M4, M5, M6. Meaning the easiest question would be this: find the acceleration of the blocks. That would be still a good question. But I'm asking you find the tension in this string. You need to find acceleration first. Without that, you won't get tension. So find acceleration first. Mm, let's see. I don't remember the answer. So how do you do these kind of questions? We use net pulling force method. You should check it out in case you forgot about that. So this guy is pulling down with M1G. Let's assume, M1 is maybe this is going up. So you have to take the forces along the string. So M2 is neither supporting nor opposing. M3G is pulling down. So that is M3G sine alpha. Acceleration is A this way. M4 is also doing nothing. M5G sine beta. This guy is also supporting the acceleration. M6 is also supporting the acceleration. So acceleration will be the net force along the acceleration. That will be M6G minus M5G sine beta plus actually it's supporting plus M3G sine alpha minus M1G by total mass. This is called net force method. You should check out the notes. Pretty nice. You will get the answer in one step for the acceleration. Is that clear, everyone? Because logically think about this. If I make all these blocks in a straight line, won't you just take the forces along the string? That M5G cos beta will never help you to go along the incline. So the only one who is responsible for motion is that sine beta there and sine alpha here. M2, M4 are doing nothing. M1 is fighting back actually. M6 is helping you down. Is that clear, everyone? Next thing, you want to find tension? How to find tension? This is something I keep telling you. You want to find tension at a point? Cut it there. So you want to find tension here? Cut it here. So just remove all this. So when you cut it, you'll get two pieces. You can take the left piece or the right piece. So here, this is tension. You can still play the same game. What is the acceleration? M6G is supporting M6G minus plus M5G is supporting M5G sine beta. Tension is pulling back minus T by total mass, which is M6 plus M5. Is that making sense? If I just take only this system, doesn't it look like there is a force acting here? I don't care what is there on the left hand side, isn't it? M6G is pulling down, M5 is also pulling down, the tension is opposing you. So these three forces are acting on M5 and M6. Are you clear with this? Take this Eka value, dump it here, you'll get the tension. So this method is pretty useful when you have multiple blocks, but a major disadvantage, it works only when all have same magnitude of acceleration. There should be something like, all are in one line or something, meaning like this. If the moment you keep something like a double pulley or something, you're gone. It doesn't work. Doesn't work for this. Doesn't work for this. Doesn't work for this three blocker system. Doesn't work for this. So it has its restrictions. So remember the shortcuts, but also understand when it works and when it doesn't work. Blindly don't use the same thing for everything. Clear with this? Let's get these two. So we have a ring there going with speed u, that is h theta, find speed and acceleration of p. Second thing, ground is smooth, 2m and m, find the acceleration of the blocks initially. If I just ask you for speed, it's a decent, easy mains question. The moment I ask for acceleration, it becomes an advance. Based on constraints. Just find cube theta by h. Yeah, speed is easy. Try a minute more. Get the second one in case you're done with the first one. So once you start solving, it's like you can keep solving. You need not listen to me. You can keep doing it. In case you don't know, you can listen. And then you can verify whether you got the same thing as what I'm saying. Let's see. String constraints. Remember, the power method or the velocity thing will always work for velocities only. Tension, tension. Let this guy go with VB. So that will be T U cos theta minus T into VB is equal to 0. This is best. There'll be no confusion with the, people get confused. Like they don't understand. Should I divide U into components or V into components? Right? Now you can give a reason and all that, but examiner things will still get confused. This is safer. So VB is equal to U cos theta. Keep it simple. Right? But if you're comfortable with the regular method, that is also fine. Now the problem with this, when you differentiate this, people think since U is constant, VB is constant, you're forgetting theta changes. So acceleration of B will be, when you differentiate this will be du by dt cos theta plus U d by dt cos theta. This term is 0. Fair enough, but that term is not 0. So acceleration of B will be minus U sine theta d theta by dt. How to get d theta by dt? Actually, you can use little kinematics and finish it off now. This is going with u. So this will be the tangential component and this length will give you omega. You can do that. But if that doesn't click, then I can go with tan theta would be, let this distance be x. Tan theta is equal to h by x, differentiate on both sides, x square theta, d theta by dt will be minus h by x square dx by dt. So from here we get d theta by dt is equal to minus h by x square theta. Dx by dt is nothing but minus u. Why minus? Because x is decreasing. And then what is x square? X is equal to h by tan theta. So take that, substitute here, take this, substitute here, you'll get the answer. Clear with this? So yeah, acceleration will require some work. This will be hu by h square tan square theta, sec square theta. So that will be sin square theta by cos square theta. So you'll be ending up with the u by h sin square theta. So if you take that and substitute here, I think you will end up with minus u square sine cube theta by h. That's your answer. Clear with this? The acceleration is not straightforward. You can use that acceleration again. If you see T1, A1, T2, E2, you can use that formula for acceleration only if thetas are not changing. What about this guy? Same story. Now, one of the most common mistake, what I see people doing here, this is what they do. They will say, okay, tension T is equal to mg. This is the acceleration. So mg cos theta is equal to ma, and they will say A is equal to g cos theta. What is the blunder with this? And this answer will be there. I have seen people doing this. The blunder with this thing, you assumed this tension is equal to mg. You are assuming this block is at rest. Clear? So that thing, just be careful with that. Tension is not mg. So how do you do tension? Tension mg. Let this be acceleration a1. Let this be acceleration a2. Now again, be careful. You cannot use the formula for acceleration here. You can't say t minus a1 plus t a2 cos theta is 0. This is wrong. Not applicable for accelerations when theta is changing. But luckily, you get the same answer. Luckily. That's because there's a certain condition. So how should you write this actually? This is always valid for velocity though. T into minus v1 plus t into v2 cos theta. This is valid. It works for velocities. v1 is equal to v2 cos theta because it's actually based on power. What is tension into velocity? Power. Since the tension is something like an internal, it does not take any energy. It simply takes energy from one block and gives it to the another block. The total power due to tension must be 0. So it works. Now when you differentiate this, d1 by dt, dv2 by dt cos theta, plus v2 d by dt cos theta. This is the actual formula. But luckily, v2 is 0 because you're asking initially. This is 0. So if you have not realized this and still you did that, you would have been lucky. Therefore, a1 is equal to a2 cos theta. But clear with that. But if it is an advanced question, they will say this block is going with 1 meter per second at this instant, and they'll give you some distances, you're dead. Clear? So that relation, or maybe it will be more than one choice question. They will say a1 is equal to a2 cos theta is always valid. It's not always valid. The moment it starts moving, that equation goes off. Clear with that? So there you're done then. Then I think t cos theta is ma2. mg minus t is equal to ma1. Done. 3 equations, 3 unknowns solved. 1, 2, and 3. Clear with this? It's a good one. So be careful with this thing. The constraints with accelerations, it's a different ballgame. If theta changes, this is a pretty good one. We got a rod there. You know that rod standard thing. Someone is pulling point A with speed u. B is there on the floor, mass m, length L. Find VB, find omega of the rod, find velocity of the center, find the trajectory of a point D, which is at an distance D from point A. Find the kinetic energy of the rod, that is rotational mechanics. If there is a magnetic field B, find VA minus VB, motional EMF. There, I dumped everything in this. Let's get all six. E and F are based on rotation. You want a hint? It has 3 digits. Alphabets, actually. IAR. Get this. D is also pretty nice one, though. I can ask even more also, draw the path of point C, draw the path of point D. There are questions like that. VB is easy. Hope you got that. B will be going down. So that's a standard thing. Rigid body constant. If there are 2 points on a rigid body, the velocity along the rod must be same. Why? Or else the rod will either stretch or compress. So this is theta. So this component will be u cos theta. This component will be u sine theta. This will be VB sine theta, because this angle will be 90 minus theta. This will be VB cos theta. So we will have VB sine theta is equal to u cos theta. U cos theta. What about omega? Omega will be, there are two ways to do with IAR, but there is one way to do. You can stand on A. So omega is defined as V relative perpendicular to the line joining. I think we did recently in that projectile thing, joining AB by distance between AB. So here u sine theta, VB cos theta, both are opposite. So that's u sine theta minus of minus VB cos theta by L. There's another way to do this. I'll show you that also. But again, this is one way to do. If you know two particles, this will end up to be u by L sine theta. That's your omega. There I got two. What about the rest? Keep going. Try. I'll give another 3 minutes. It's a worthy question. It has multiple things. what about velocity of the center? That's an interesting one. So velocity of the center, if I take this coordinate as x comma 0 and this coordinate as 0 comma y, then the position vector of C will be x by 2 I cap plus y by 2 j cap. If you want velocity of center, differentiate it. Half dx by dt, half dy by dt. Dx by dt is velocity of A. D minus vb by dt. Minus vb because it's coming down. There, that's your answer. And they can even ask you the trajectory of the center. Trajectory of the center will be xc square plus yc square. If you square them and add them, you will end up with x square plus y square. That is L square by 4. It's actually equation of a circle with origin as the center. And so in case that looks confusing, you can do this also. You can take this as coordinates L cos theta, L sin theta, and you can work out from there also. That works. So let's find D actually, that you'll understand. If you take D ka coordinates, this will be D cos theta. So its coordinates will be L by 2 cos theta minus D cos theta, comma D sin theta. Those are your coordinates. So xd square by L by 2 minus D whole square plus yd square by D square is equal to 1. D is going in an ellipse. Clear with this? D is going in an ellipse. Center goes in a circle. If D is equal to L by, this is L cos theta actually. Right? If you take center, if D is equal to L by 2, it becomes center. Center goes in a circle. A and B go in straight lines. So there are actually 3 different trajectories on this rod. So every point other than the center and the 2 corners will go in ellipse. So all these points are going in some kind of a weird ellipse. Where the center of the ellipse is this thing. X is L minus D and Y coordinate is D, and then you're up. Clear with this? Then kinetic energy of the rod. Now there's no normal way to do this. We have to do IAR. Now what is IAR? How to find IAR? You should go check out the notes, but this is the thing. If you want to locate IAR, you need at least 2 points on the body whose velocity ka direction you know. Right? I don't care about the actual velocities, but at least you should know the directions. So here I have 2 points, A and B. So A is going horizontally and B is going vertically. Then what you do, draw a perpendicular to these 2 velocities. So imagine we have some random body there. A is going like this and B is going like this. So what you do, drop a perpendicular to line A, drop a perpendicular to line B. The point where they meet is your instantaneous axis of rotation. And the logic is this thing, you know, when you stand on IAR, you think everyone is going in a circle. So think about this. If everyone is going in a circle, and these are concentric circles. So for a concentric circles, if you take any point and draw a normal, shouldn't they always meet at the center? That's your IAR. So for B, when you draw, this is your IAR. Now, if you go and stand on IAR, IAR is a special point. It is useful to find the speeds and it is useful to find the energy. So the kinetic energy of the system, now see, this is going with VA and this distance will be L sin theta. What is omega? VA by perpendicular distance. You'll get the answer in one step for omega. What is the kinetic energy of the rod? Half moment of inertia about IAR. So you can assume it is rotating about IAR at that instant into omega square. And how do you find IAR का moment of inertia? You can calculate this. This distance comes out to be L by 2. Parallaxes theorem. Half ICOM, which is ml square by 12, plus ml by 2 whole square. Omega will be u square by L square sine square theta. There will be ml square by 3. You will end up with mu square by 6 sine square theta. Clear with that? Check out the calculations. I could be wrong, but yeah. That's a pretty good one. So there is no normal way to figure out the kinetic energy of this. And next thing. Now, once you got this omega, you can play like this also. Do you guys remember this EMF? When you have a rod rotating with omega in presence of a magnetic field, if this is your hinge, the potential difference will be how much? B omega L square by 2. So stand on the IIR, take it as O, and there's a magnetic field B. So you can find VA minus VO will be B omega L sine theta whole square by 2. So you're treating OB as one rod and OA as one rod. VB minus VO will be B omega L cos theta square by 2. So you want VA minus VB, subtract them. Check which is positive, which is negative though. B omega by 2 L square sine square theta minus cos square theta. Is that clear, everyone? You just have to go and stand on the IAR, right? And this is what you think. You will think there's a rod here at A, which is L sine theta. You will think there's one more rod here at B, which is L cos theta. There's a magnetic field B here, and both these rods are rotating with omega. And indirectly, I'm asking you find the potential difference between A and B. Clear with this? Clear? So this rod question can come in how many places? Rotational mechanics, electromagnetic, EMI. You can ask as PB, constant equations, the trajectory equations, and whatnot. Clear?
Can we take the effective power from IAR to the
You
setup?
can't take. You can't take. There'll be pseudo force. IAR is instantaneous at rest, but it is still accelerating. Every time the rod moves, IR is also changing now. It's a non-inertial frame. You remember that thing. IAR, use it only for velocities and energies. Never use it for torques. Clear with this? Take a break. Come back in 10 minutes. We'll continue from here. Let's go ahead. Let's get these two. So we have a trolley there. Force F is equal to T, T is time, and every second R kgs of rainwater is falling into the trolley and getting collected. Find the velocity of the trolley after time T, initially at rest. Second thing, rocket ka mass 200 kgs. Gas is coming out with 200 meter per second relative to the rocket. You're ejecting 20 kgs per second. Find the acceleration of the rocket at 5 seconds and speed of the rocket after time T. You can also call this thing as variable mass system, or you can also put it in Newton's second law. Yeah, doesn't really matter. So let's go. Let's go. How to do this? Now, most people will think, you have to integrate and all that. You don't need to do all that for 33A. There is a much faster way to do this. This damn thing. Just move it to trash. Hmm. Now, you want to use that stuff, we can do it, but it becomes a little complex. There's a much faster way. What is F? dp by dt. So change in momentum is integral f dt. So what is change in momentum? M final, V final minus M initial, V initial is equal to, this will be T square by 2. V initial is 0, you're starting from rest. Mass final, M plus RT into V is equal to T square by 2. Therefore, velocity will be T square by 2 into M plus RT. Check. You want to integrate and do that? Then the equation will be F is equal to M dv by dt, but M itself is changing, so it's M plus RT dv by dt, and this would be minus V dm by dt, that is minus VR. Be careful, this should be the relative velocity. So when the trolley is moving with speed V and the rainwater ka horizontal velocity is 0, V relative is V only. This will be F minus VR M plus RT dv by dt. This is the relative velocity of rain with respect to trolley. It's been a little confusing, but you could do it much faster. The trolley is going forward, the tilting rain is going backward. Integrate this, you'll get the same answer. You won't get exponential. You get both the sides log and that thing goes off. What about the rocket propulsion? I hope you remember the formula for thrust force. The thrust force is given by U relative dm by dt. So then you can simply take the rocket. The thrust force will be U relative, which is 200. dm by dt is 220. Your weight will be mg. This will be your acceleration. So that will be 4,000. After 5 seconds, how much fuel is burned? 100 kgs is burned. It will be 100 into g minus 100 into a. That is 30 meters per second square. This is 4,000. This will be mg will be 200 minus 20t into g is equal to 200 minus 20t into acceleration, which is dv by dt. You can integrate this. You will get the velocity from there. Clear this. That's your standard result, for the velocity of a rocket. Let's get this thing. So we have a rod applying 2F and F, tension at X. You have a rod, you're applying F and F, find the maximum shearing stress or find theta for maximum shearing stress on this area. So you can frame elasticity questions on this. This is a very standard question. You should definitely be very comfortable with this. So this is your acceleration, which is F by M. And if you cut it here, so whenever you want to find tension, cut it there. Then when you cut it, you get two pieces, left and right. You can choose any one. I will choose the right side. So this is 2F. This is T. This mass will be small m. So the mass changes mx by L. So 2F minus 2 is equal to mx by L into acceleration. So we get tension will be F into 2 minus x by L. That's your tension. And you should know how to find these tensions because exam may, right? I'll give you Young's modulus, area, and they'll ask you find the elongation in the rod or I'll ask you find the energy stored in the rod. Then I hope you know the formula for that. So this will be the tension as function of x. What about theta for shearing stress? Now here, if you see tension is T everywhere, this is the tension. So we divide tension into two components. That is theta, this is theta. This will be T cos theta. And remember, this area is A. So this area will be A by sine theta. So shearing stress will be tangential force by area of cross section where it is acting. So on this red area, the tangential force is T cos theta, and the area acting is A by sine theta. Clear that? So that would be F by A sine theta cos theta, which you can write as sine 2 theta by 2. So when will this be maximum? For maximum, theta must be 45. When sine 2 theta is maximum. Clear with this? So if you take a cross section at an angle of 45 degrees, you will have a maximum stress on this. Shearing stress is tangential force by the area where this thing is acting. This is cross section, not the red one area. Clear with this? Let's get these things. Springs. We have a 10 kg, 10 kg, we have a 10 kg, 5 kg. Find the reading of the spring balance. We have a person inside the lift standing on a weighing scale. System is at rest. Find the reading of the weighing machine. If the lift is going up with A, then find the reading of the weighing machine. This is another model that if you remember, weighing, this apparent weights. This was easy. So what does the spring balance measure? It actually measures tension in the string. And what does it show? So it shows the tension. So here, what will be the tension? 100. So the reading will be 10 kg. So the spring balance will show a reading tension by G. What about this guy? 10 and 5 kg. What will that show? That would be a good mains question. How do you do this thing? You just have to find the tension here. Let this be T, let this be T. If you think about it, this is actually an Atwood machine. If you divide them, you will get the tension ka value from here, which is 10, 5, 50 by 15. You will get 200 by 3 newtons. So the reading will be 20 by 3 kgs. Right? What about this thing? If you look at this, the whole system, if you take this thing as a whole system here, you can clearly see this is one tension. This is one tension. We get 2T is equal to 60 plus 40. That is 1000 newtons. So tension will be 500 newtons. Now, if you draw the FBD of this man, the string is pulling him up. His own weight is 600. This is the normal reaction, and this is 500. So we get normal reaction is equal to 100 newtons. So the reading will be, remember, weighing machine will show normal reaction by G. It will show 10 kgs. And this thing is fine. So here the normal reaction will be M into G plus A. The reading will be N by G, which is M into 1 plus A by G. That's what the weighing machine will think the reading is. Clear with this? This is a good one. Based on rotational mechanics, but yeah. So we have a faulty beam balance, meaning the thing is not in the center. This side is M. So when you keep the block of mass M here, we need 9 kgs to balance. When you keep that M on the right hand side, it requires 4 kgs to balance. Then what is the actual mass of the block? See, if it was properly working, then when you keep it on either side, you should put the same mass, isn't it? Because it's not working properly, when you keep it on the left hand side, you require 9 kgs on right hand side. When you keep on the right hand side, you need 4 kgs on the left hand side. So basically that center point, it's not in the center, it is messed up. Then what is the actual mass of the block? This is based on torque. So let this distance be x and let this distance be y. Since the thing remains horizontal, the equilibrium must be same. So this is m into x must be equal to 9 into y, and this is 4 into x must be equal to m into y. Divide them. M by 4 is equal to 9 by m. M square is 36. So you can actually, this is a root over m1, m2. That's your answer. It's a geometric mean. So if the thing gets balanced with m1 and m2, the actual mass will be root m1, m2. These are another good questions. We have two blocks, 2m and m. Initially at rest, you're cutting the spring here. Find the acceleration of the blocks just after cutting. How do we do these kind of problems? Step 1. First, find the forces in the spring. Step 2. Whichever spring you are cutting, that tension will be 0. The other springs don't care. They will still remain the same. Step 3. Draw the FBD and solve. So step 1. Find the forces in the spring before cutting. So this spring force will be 3 mg. I'll just call it T2. This spring force will be 5 mg. Right? Now you are planning to cut it here. The moment you cut it there, T1 will still remain 5 mg. That spring does not know, and T2 becomes 0. Draw the FBD. So for 3 mg, T2, this becomes 0. This is 3 mg. So you will just freely fall with G. That's your answer. For 2m, see the upper spring rate. See, springs have this tendency. They will apply force only based on the elongation. They don't care what is the external forces applied. So this is 5 mg. This is 2 mg. This thing will go up with acceleration. So that would be 5 mg minus 2 mg by 2m. A1 will be 3g by 2. So this block will fly up with 3g by 2 and the 3m block will fall down with g. Is that clear, everyone? This is another good one. This is really a good one. So we have a ball there, which is at rest. Two strings are there, theta, theta. Find the tension in this left string just before and just after cutting the string. Initially at rest, what find the tension? You just cut the string on the right side. What is the tension in the left side? They did us something like this before. Find the ratio of tension before and after cutting. This is another very good model. So the first part was easy. Before cutting, it was easy to find. That will be tension, that will be tension. This is theta, this is theta, this is mg. 2t sine theta is equal to mg. Great. What happens when you cut it? The moment you cut it, this thing starts swinging like a pendulum. And the most common mistake what people do, this is theta. They think t sine theta is equal to mg. That's a blunder. Why is that a blunder? Because the moment you cut it, this thing is swinging like a pendulum. This thing actually has an acceleration. Are you clear with that? There is an acceleration there. So that means there is actually a vertical component and there is a horizontal component of acceleration. So if you try to write that equation, the equation is actually this. Mg minus t sine theta is equal to mass into Ay. So Mg is not equal to t sine theta. That is a mistake that happens. So how do we solve this? Since acceleration is in this direction, we resolve the forces along the acceleration and perpendicular to this thing. So treat this as x and y. That makes your life easy. There is no acceleration along the string. Right? So because initially velocity is 0, so there's no centripetal. So we can write t is equal to mg. That is theta 90. This is 90 minus theta mg sine theta. There, that's your tension there. So initially mg by 2 sine theta, now it is mg sine theta. Are you clear with this? So be careful when you cut, you should treat this thing as x and y. So resolve mg component, because if you try to write in the vertical direction, there is an acceleration. Mg is not t sine theta. What about this guy? This is another good one. We have a force F. Initially, all springs are in natural length. This is a pretty good question. You can play it in multiple places. You can ask this in SHM, right? I can ask in work power energy. I can ask it in this. So there, I did ask actually SHM also. So we have a force F applied, and the block F is pulled slowly till equilibrium, right? Find the distance traveled by the block and find the time period for small oscillations. How to do this thing? There is a formula for this. Spring equivalent. Listen to this. So when you have multiple springs, the formula is T square by K equivalent T1 square by K1 plus T2 square by K2, so on till Tn square by Kn. Where, what is T here? T is the total tension on the block. And T1 is so Tn is the tension in the nth spring. This actually comes from conservation of energy. Think of like this. What is the energy stored in a spring of kx square? Multiply k and k. Then this will become kx whole square by 2k. But what is kx? Tension in the spring, isn't it? So this is the energy stored in one spring. So if I add all the energies of the spring and I'm trying to replace with one spring with the same amount of energy. So this thing is from conservation of energy ka formula there. Quite useful to get K equivalent. Now let's find the things. Start from anywhere. Let this be tension T. If this is T, then this will be 2T. This is also T. Then this is also 2T. Perfect. So on the block, how many tensions are acting? 2T and 2T. So that is 4T whole square by K equivalent. And this thing is, that spring cut tension is 2T, 2T whole square by K. And this spring cut tension is also 2T whole square by 2K. And this will be T square by 3K. T square goes off everywhere. This is 16 by K equivalent. 4 by K, 2 by K, 1 by 3K. Solve this, you'll get the K equivalent. That means you can replace this whole thing with one block with a K equivalent ka spring. And you're applying force F. F is equal to K equivalent into X. That is your distance moved by the block. What's the time period for oscillations? 2 pi root over m by K equivalent. Remember that if you have one spring and one block, the time period is 2 pi root over m by K. Clear with this? Then it becomes easy if you know this equivalent ka thing. This I think we saw in SHM, but there I can also play it in NLM also. Find the distance traveled by the block till equilibrium. Find the energy stored in the spring till F. So there are multiple things I can play in, Or if the block is initially applied with a constant force F, find the amplitude. Amplitude will be the same thing. The initial position will be extreme position. The equilibrium position will be the mean position. The distance is the amplitude. Clear with that? So you can play all that stuff. Yeah, this thing we did in elasticity. So I think there's no point in doing it again. Let's get this thing. We have a block A, block B moving with 3. There's a ring here, which is moving on a horizontal rod. Find the velocity of B. So what we do in this? Again, constraints. So get the tension. So this will be tension. This will be tension, tension, tension. This is 60. So this is also 60. This is also 30. So on A, the forces will be T cos 60 into VA. For the ring, horizontally, you're pulling with T cos 30, and this tension behind is pulling with T cos 60 into velocity of the ring plus minus T cos 30 into 3 is equal to 0. Again, power method, everyone. T1 V1, it's actually the formula is T1 bar dot V1 bar. So you should take the tension in the direction of velocity. Are you clear? The ring is going right and left, so take the total tension on the ring acting in the horizontal direction. And then just add up all the powers. Total power must be 0. Let's get these 4 questions. We have a chain on a table. Find x if the chain does not slip. Chain is about to slip, to find x. Find the minimum force required to move the block. Standard result you should know. An insect is climbing on a surface, y is equal to x cubed by 3. Find the maximum height it can climb. You are applying a force 20 root 2, mu is 0.2. Find the acceleration of the block. Let's see. So this chain is pulling with what weight? M by L gx, and this friction will be mu M by L minus x into g. Equate them, we'll get the answer. What is the minimum force required to move? F is equal to mu mg by root over mu square plus 1. You should know the result, the standard result. And this happens when tan theta is equal to mu, angle of repose. You won't have time to derive that. This is the direct result. You should know that. The question is minimum force required to move the block. No one said force is horizontal. What about this thing? Again, same thing. The insect can climb up to angle of repose. At this point here, your mg sine theta and friction becomes equal. After that, you start slipping. So we get tan theta is equal to mu, which is given as 1, and tan theta will be x square. X is equal to 1, y is equal to 1 by 3. So maximum height you can go is 1/3 of a meter. Find the acceleration of the block. This is 20. Here, another most common mistake. People write friction is mu mg. Friction is not mu mg. Friction is mu into n. And n is not mg here. N is 80. That's the most common mistake that happens. So that will be 20 minus 0.2 into 80 is 16 is equal to 10a. A is equal to 0.4 meter per second square. And I can ask you more questions on that. Find the work done by the force in 2 seconds. Then I'll use S is equal to half 80 square, displacement, and then force into displacement. Clear with that? We have two blocks, M and 2M, on a disk, and the disk itself is rotating with omega. All surfaces are rough, mu. Find the maximum omega so that the blocks don't slip. It's the same picture. I'm just, kept it magnified here. I hope you got the question. So there are two blocks like this, M and 2M, at a distance r. You kept it on a disk and the whole disk started rotating with omega. All surfaces are rough. Find max omega so that the blocks don't slip. Step 1, draw the free body diagram. Now, when you draw the FBD, right, the important thing is friction ka direction. How do you find the direction of friction? So this is how you do. Always assume, imagine there is no friction. Okay? If there is no friction, who will actually try to move? The 2M will have a centrifugal force, 2M omega square r. This guy will have a centrifugal force, M omega square r. So if there was no friction anywhere, what would have happened? Who would have moved out? The 2M will try to go to the right and M will try to come inside, isn't it? That means this friction will try to oppose 2M and will actually support this guy. That is how you get the direction of friction. Assume there is no friction on the system. See how they would have moved without friction. So you try to stop that. And then you have tension here. Let's call it F1. Yeah, one more F2 here. And this is one more tension here. And done. Since you're asking for maximum omega, this will be M omega square plus F1. So frictions are maximum. This will be 2M omega square will be tension plus F1 plus F2. Take the tension, substitute here. 2M omega square. This will be M omega square R plus 2F1 plus F2. This is m omega square r, and F1 will be 2 into mu mg, and F2 will be mu into 3 mg. This will be 5 mu g by r ka root. Clear? So the centrifugal forces are trying to drag it out, but because they're connected by a string, 2m dominates. So 2m is trying to go out, so both the frictions will be inward for 2m. These are another good problems, 2-block problems. Hope you remember. Friction wedges are one of the good things. They're applying 8 newtons, point to find the acceleration of the blocks. Second thing, find F max so that the blocks go together. So how do you do these kind of problems? Again, listen, whenever you do 2-block problems, you directly don't draw the FBDs. You start with an assumption. We will assume both the blocks are going together. Why? There's a problem. If both the blocks go together, F need not be maximum. If both the blocks slip, F is maximum. So we are confused. So whenever you see 2-block problems, always start with an assumption. Assume blocks go together. If the blocks are going together, then we have acceleration A is equal to 8 by 8, 1 meter per second square. Then choose any one block. I will choose the 5 kg block. This is the friction, and the acceleration A is equal to 1. We get F is equal to 5 newtons. Remember, what is this? This is required friction. So friction is saying, if you give me 5 newtons, I can make sure the blocks will go together. That's your assumption, right? You got the value of the friction under the assumption they're going together. Fair enough. But what is F max? F max is 0.2 into 30, which is 6 newtons. So the friction is less than F max. So friction is saying, give me 5, I will make them together. And you're saying I can give you 6, so my assumption is right. So therefore, answer is acceleration is 1 meter per second square. And the friction between them is 5 newtons. That's what they'll ask you. Friction is not 6. Job of the friction is not to apply maximum force. The job of a friction is to make sure the slipping doesn't happen, to make sure they're going together. So if friction can give 5 newtons, they can go together. Why the hell will it give 6 newtons? If it gives 6 newtons, 3 kg will go faster than, 5 kg will go faster than 3 kg. Doesn't even make sense. Are you clear with that? So when you do 2-block problems, this is how you do that. In case you're still confused, you're not clear with this, you should definitely check out. I spent one full class only on 2-block and 3-block problems in the notes. But this is how you handle 2 blocks. You don't start with an assumption. Don't put F maximum. The second question, find F max if blocks go together. Okay, here it is fine because you're asking maximum force. So it must be on the verge of slipping. 2 kg. Now this you can take it as F max because you're on the verge of slipping. So actually you can take the whole thing, acceleration is A. Then we get F is equal to 8A. then F max must be equal to F by 8. Or let's keep it as F only. So F is equal to F by 8 because they're going together. And this must be less than equal to F maximum, which is 0.3. Wait, there's a friction on the ground also. So now see, if they're going to move together, that means the ground must be slipping. This F max must be equal to 8. Therefore, acceleration will be F minus 8 by 8. Then choose any one block. Friction will be forward. Acceleration F is equal to 2a, which is F minus 8 by 4. This must be less than equal to F maximum, which is 0.3 into 26. F minus 8 is 24, and F must be less than equal to 32. 32 is the maximum. Clear with this. So be careful. In two blocks, you don't assume F is maximum every time. Let's see a few more on this. I think we'll get a better idea. Try these three cases. Mains mein they won't ask 3 blocks. Even in advanced mein 3 blocks is not there in the portion, but 2 blocks you should know extensively. First case, ground, there is a friction. This is 0.1 between the blocks, ground is 0.3. This is smooth, 0.1 smooth, and this is 0.3. Find the acceleration of the blocks. Then if you got these three, I think your 2 blocks are good. If you check out the class notes, we did with F versus time graph. That was much better, but yeah. How do we do this? Same story. Step 1, assume they're going together. Acceleration. This friction will be actually first. So first you need to check something actually in this bit. Let's check. Here, what is the maximum friction? That's 0.1 into 5. That's 5 newtons. What is this F max? That's 0.3 into 15. That's 45 newtons. Now, if you just look at the 10 kg block, the only person who is moving the 10 kg block is the friction above, and there's the friction on the ground. Since friction on the ground is greater than F1, 10 kg will never move. Is that making sense? If I ask you this question, who is moving the 10 kg block? It's not capital F. It is a friction between 5 and 10 which is moving the 10 kg block. Is that making sense? And that friction is always less than F maximum. To break the friction on the ground, you need 45. And the friction between 5 and 10 is 5 newtons. So no matter what you do with the 5 kg block, the 10 kg will never move. Clear with this? So acceleration of 10 kg is gone, 0. And then 5 kg though you can calculate. Now 5 kg will behave as if it is on a ground basically. This is 25 and this is 5 and this is acceleration which is 4. You're done. What about the second one? Second one is your standard equation, 25, and the ground is smooth, so it has to move since the ground is smooth. So we will do the same story there. That will be acceleration is 25 by 15. Then you choose any one block. We'll take the 5 kg block. This is the friction. This is the acceleration. This is 5 into 25 by 15. That's 25 by 3. So friction is saying, give me 25 by 3 and I will make sure both will go together. This is something like 8.333 newtons. But what is F max? F max is 5. So our assumption is wrong. Therefore, block slip. So that is the advantage. If your assumption is right, then you're done. If the block slip, therefore F is maximum. So friction is trying its best, but still it can't stop the slipping. So when you draw the new FBDs, you just put F max. Now you can put F max confidently. Clear with that? What about C equation? Can you do that? I'll give you a minute. See, if the floor is smooth, it has to move. There is no other alternative. Same story, assume both are going together, then we'll have 10 minus 5 is equal to 5a. A is equal to 1 meter per second square. Choose any one block. I will take the 2 kg block. This is the friction, this is 5, and this is A. We get F minus 5 is equal to 2A. The friction is 7 newtons. F max is 0.3 into 20, that is 6, so gone. So required friction is saying, boss, I need 7, but I can give only 7. Therefore, my assumption is wrong, block slip. You always need to check. And then if the blocks are slipping, then you're fine. Now you can take F max confidently. This F max is 6. This is 5 Newton. So this acceleration will be half. This is 10. This is 6. And this acceleration will be 4 by 3. You always have to check. Is that clear, everyone? That's a bit about it. So next class when we catch up, we'll continue from here. We will do little more on friction and then circular, and we'll enter into work power energy. Take a break, right? Have your dinner. Come back by 9 o'clock. We'll start by around 2 o'clock. 9 to we will start the speed test. Okay, with that we'll wrap up for the day. So do come back by 9 o'clock. Those are out, you can stay back and ask, or else you're free to leave. And rejoin again. I will restart the meeting.